Hello, everyone. Good morning. This is an overview of our experiences over the summer working on Scion, a network architecture that offers highly available and efficient point-to-point packet delivery. Scion, as a project, has been worked on at CMU since 2008. We, as interns, delved into the business side of things and also built an application, making it Scion Aware. Scion Aware is a term that we coined, which sort of means making an open source code or legacy code with Scion capabilities. I will hand it over to my teammates to talk further.
Yeah, let me introduce our Scion and team member. John is our president. He works on the Scion network. And Jeffrey is our project advisor. She gives us lots of helpful advice. And this summer, we have 3 interns, Xinran, Hamsini, and Xiaoxuan. They are all current online students. Also, we have partners, Scion Lab and Equinix.
Our project goals for this summer is to identify key industries and applications that could benefit from Scion, set up Scion nodes on Scion Lab, port applications over to Scion, develop Scion applications, and identify areas for future work by our students. So let's talk about BGP hijacking. BGP hijacking is a network control threat. By maliciously manipulating BGP IP prefixes, an attacker can reroute traffic in order to intercept or modify traffic. There are currently a lot of news reports about BGP hijacking, so the network traffic hijacking is real and has been happening for years. BGP has long been a weak point of the internet.
And there is another problem called the malicious TLS-CA, and a CA is a certificate authority. It issues a digital certificate. Corrupt CA has been used by hackers to generate fake digital certificates. Since the end user trusts the CA and the certificate is signed by the CA, the end user trusts this fake certificate. There has bad influence. For example, the class web crypto user lost 1.9 million after a combined BGP hijack and fake TLS certificate issued by malicious CA. So organizations should no longer trust arbitrary DNS register and TLS CA across the internet. Scion can solve this problem. Scion allows the user to determine which CA to trust.
After the inception of the internet about 30 years ago, nothing much has really changed. As my teammates mentioned, it has a lot of security threats, including BGP hijacking and malicious certificate authorities. DNS and TLS are also the kill switches of the internet. So a central body could take a website out of business if they intended to. So not only does Scion solve the security issues, it also decentralizes based on the network architecture. It has 4 main advantages. Control. The user has complete control over how data or packets traverse in the network. You can also control it based on features like latency. Transparency. After data has traversed from point A to point B, you know exactly where all it has traversed. Availability. Since Scion is available of every path that a packet can take, if 1 or 2 networks fail, it switches easily to a different network and hence is very resilient. Trust. The user can attach itself to an isolation domain or create an own isolation domain of computers that it trusts, and hence Scion incorporates and increases trust.
And Scion has been used in production since 2017. Look like this picture. It has great deployment in Switzerland, like the Switzerland ISP. Swisscom is the largest ISP in Switzerland, And Switch is non-profit ISP that provide connectivity with like university and other research institute. They all use Scion network. And Scion has customers in production, like the banking industry. There has been great multiple various banking use Scion network, and it has great function like interbanking clearing. And we have Scion Lab for research. Scion Lab is a global tested network available for all developers to research on. We have our ionized Scion on the Scion Lab. We open two physical machines. One is Scion. It will connect to the CMU attach point. And we have the Scion 2 physical machine. It will connect to the Macbird attach point. And we use the Equinix. It's a hardware provided by the Equinix Mantle. It utilizes data center in Frankfurt, Germany, and Washington, UC. It connects to the North American and European isolation domain. Scion has a great function called path-aware networking. Look at this picture. We use Scion traceroute to trace the remote address, and it will show 9 routes available on this picture. And based on the metric like latency and bandwidth, we can choose the path which is the best. Here is a video. We'll introduce how to choose a path use Scion network in detail.
Scion is a path-aware networking infrastructure. I'm going to show how to choose paths from the end host. First, we log into the host by SSH. We can configure the host with the Scion AS using Scion Lab config. You can find it in Scion Lab document, so we just skip that. Then we use the systemctl to restart the Scion service. And we can verify your host has been assigned the correct AS with Scion address command. It will show the address. Then we verify connectivity with the ping command. Pin a remote address. Then we use Scion show path. The Scion show path command will display the paths that are currently available to a remote AS. We can find the lowest latency path from that command. So the lowest latency is the path 2. And we can choose path 2 from another command called Scion traceroute. With the Scion traceroute -i, we can choose path. We type number 2, choose the path.
After having understood Scion as a technology, we began delving deep into understanding what target markets we can focus on. Based on factors such as open source acceptance, financial impact of hack, impact of path selection for the business, we came up with 3 main target industries. Web 3.0. It's an idea for a new World Wide Web and which focuses on decentralization. Having a network architecture which helps with decentralization will be pivotal to realize the implementation for Web 3.0. Industries such as critical infrastructure and high availability industries have very high cost of failure when the network fails or the network is hacked. And hence we chose these 3 industries. We next zeroed in on companies that were in these domains to talk to them and understand what we could do with Scion for them. We spoke to Realty.co, a real estate company on a blockchain, who said they would really benefit with a Scion-aware Ethereum implementation, so it could reduce the latency for their smart contract business. PNC Bank wanted to have a Scion-aware back end in their legacy code to prevent user hijacking. Teletracking said they could use open source software Apache and NiFi with Scion capabilities to secure medical data transport for their software as a service offering. Verizon's real-time communication platform, PubNub, could be really secure and reliable based on Scion-aware capabilities. Digital sovereignty through Scion. There's been a lot of research in the past about cloud sovereignty, where we mostly talk about data storage in a particular geographical region in the world. But not a lot has been spoken about how data can be traversed in a geographical boundary. This is possible through Scion. In the current geopolitical climate, a country like Sweden would like to have all their data traversed within the geographical boundary and not to a country like Russia. With a suite of software products with Scion-aware capabilities, this could be possible for a country like Sweden with Scion. When we spoke to a company called Akamai, which is in the content delivery network space, they said they had some issues with reducing their latency further and also with rapid recovery after WAN failures. We realized that we could solve both those problems with Scion, and we wanted to develop a proof of concept for them. So introducing Varnish Scion, which is an open source software called Varnish, and we have enabled Scion capabilities for this open source software, which is essentially a reverse proxy and cache. I want to hand it over to my teammates to explain more.
So the Garnish is one of the projects we've been working on during the summer. I don't know if you heard Varnish before, but Garnish is a golden version of Varnish that can be fit in the Scion network architecture. We can simply view Garnish as a cache and a reverse proxy. So whenever a client sends an HTTP request to the Garnish will check if the request has been cached or not. If it hasn't, the Garnish will send a Scion request to the origin server, and the origin server will send the data back to the Garnish, and the Garnish will cache the data and send the data back to the client. So the next time the client sends the same request to the Garnish will just directly send the data back to the client without visiting the origin server. So the main difference between a Scion Garnish and an ordinary Varnish is that between the path of the Garnish and the origin server, we are using a Scion network architecture. And the Scion is a path-aware architecture. So for every request, we can choose path between the Garnish and the server. We can pick paths by our preference. Say if we want to send a small piece of data, we can choose latency. And if we want to send a large file, we can choose the bandwidth. If we don't have any request on the latency and bandwidth, we can go for the price. And our Garnish project is fully open source, and you can check it out via this GitHub link. And this is a demo for our Garnish project.
The white terminal is for the origin server, and the black terminal is for the Garnish server. And we use a web browser to send requests to the Garnish server, and we can see the first request is a miss in the cache. And after we refresh the page, the request show a hit in the cache. And now I will try the interactive mode so that we can choose paths between the two servers. When the browser sends requests, we can see from the Garnish server that there are 40 different paths for us to choose. I will just pick a random number. Let's say 6. Okay. And the first request is a miss. After refresh, the cache is a hit. Then I will show you how to choose paths based on your preference, because sometimes we don't know which routers are the best. we can see there are 5 different preference options, and I think I will just go with the first one, latency. Okay, so now the terminal shows the path we choose. Okay, this is the path-aware networking function in Scion. So what?
And this summer, our intern have the Scion AI development environment. We set up the Scion environment on multiple machines. Look like this picture. We set up on virtual machine called the VirtualBox on the Equinix mantle. And each virtual machine can have a different Scion AS node. And we can also set up from the local machine and the physical signing machine. Also, we install the Scion network from the Ubuntu package and then develop Scion application. There are some instructions like the Virtual Studio for remote development, and we post our material on the GitHub repo. You can find it from the link.
To make our application Scion aware, we need to make some modifications in the codes. And the most frequently used library in the codes is Pine library. And Pine is the acronym for Path-Aware Networking. These are some critical lines in the codes. First, we need to set some flags to provide the remote address and path selection policy. And we can use policy from command line to choose paths interactively based on the route sequence and preference. And we can use a resolve UDP address to resolve a server's address string to a Scion address. And the path selector will keep using the current path, starting with the first path chosen by the policy. So with all the path selector, you resolve the UDP address and the policy, we can set a connection between the garnish and the origin server.
Also, we use the QUIC protocol on our Garnish application. QUIC is a reliable transport protocol that refines the basic operation of the IP TCP protocol. There are 3 important modifications on our Garnish application. The first is path-aware networking dial QUIC. This function establishes a new QUIC connection called session to a server at the remote address. Also, we use the stream function. Use streams of bytes that can be read from and written to, and post it to the data to the web browser. Also, we have the master generate self-signed certificate function. It generates private key and a self-signed certificate. This certificate is used for TLS with insecure skip verify.
To summarize everything, after having spoken to multiple companies in the domain, the interest for Scion is real. They also showed interest to make their legacy code Scion aware. And after having worked on an open source project to make an open source code Scion aware, we understand that it is very straightforward. In conclusion, we believe that it's the right time and context and has business value to take Scion to market. After having brainstormed with my teammates, we've come up with future projects that the I&I can work on. And those are to form an independent performance metrics to compare Scion-aware code with those which do not have Scion capability. Pen testing to see if a code is hardened for real-world use, and building a complete software suite for realizing the digital sovereignty dream. Thank you.
Great presentation. Great presentation. First off, good news. Congratulations, you all passed. In case you're worried about that. I did have a couple of questions I'm interested in hearing about. So about week 2, week 3, we went through the list of applications you had put together. Geez, maybe there were more than 20 applications on there. And you went through the exercise of reducing it down. Maybe you can talk a little bit about your experiences going through taking that list of 20 and how you got it down to your final decision on the CDN path and sort of the different metrics you used to decide to pick the one that you did.
I mean, I can take that. So we chose a lot. We went very broad on the applications that we chose, everything from message buses to blockchain to critical infrastructure products and in the open source space. I think we realized with CDN, the problem that we finally went up with is mostly because all the problems that they had, we could sort of easily solve with having Scion capabilities. And we thought maybe we could first have a proof of concept with this and solve a lot of their problems, and then maybe move to other products as well.
Okay. And then from a technical point of view, how did you end up picking Garnish over, because there's a number of different reverse proxy implementations out there. So why Garnish? Why this particular code base did you start with?
Yes, we picked Garnish because for the Scion applications, we are mainly using Golang language, and the origin Garnish repository is using Golang. This is the first reason. And the second reason is that we are all new to Scion, so we need to pick we can easily modify the application, that kind of application. So I think Garnish is really straightforward. The ideas is really straightforward for us to understand, and the code is handleable for us. So we pick Garnish.
Okay. So any potential interns for next year, what advice do you have from them from a business point of view or technical point of view, places that were helpful for you getting this work done? Any advice you'd like to hand on to them?
Yeah. I think for the future we have provided some material for them. First, we have set up the Scion network environment and on the INI signing physical machine, and you can find it from the GitHub repo. Also, we have the document to specification these steps we can use. Also, we have set up the Scion on the Garnish application and provide the modification function that you can find, and you can use it on other application that using Scion. I think it will work. Yeah.
To add to that, Scion also is open source. There's a lot of documentation, example code, so you can go back and look into that for examples.
Yeah, I think you relied on a lot of that too. Just going back to the Scion repo, and there's a lot of sample code there that I think was valuable for the team too. Last question: toughest part of the project. What was the toughest thing? Was it technical? Was it working as a group? Was it getting Visual Studio to work? Because I know there were a couple of firewall blocking port issues there. What was the toughest thing you think you had to overcome in this project?
I mean, from a non-technical point of view, there was definitely, I think, reaching out to people a lot more, reaching out to a lot of companies, gaining interest for them, talking to them. And I think summer is like a really short time. So maybe, I think that it was just a little time consuming and a little stressful, but other than that, it was smooth sailing.
Yeah, I think for the technical part, since we start this intern from scratch, we need to know more about Scion network. It will time consuming for the start, but we can handle it if we have good communication with our mentor and our fellow intern. Yeah.
Yeah, just like Xiran said, Scion is a totally new thing for us, so it's really hard to get started. We have a lot of things to read and learn, and the language, the Golang language, we haven't learned before, so we need to start from the scratch. So I think this is the most difficult things for us to do. But once you get started, you will like find it easier to do things.
Yeah, that's very true. You have to learn Golang and Scion, right?
Yeah,
Two
yeah.
things to get this done. I know you're all hoping that you will never have to do anything at all with Scion in the future, but I do have a quick thank you that I'd like to give each of you. Give me a second. You might laugh when I give these to you. I have for you autographed copies of the Scion textbook.
Thank you. Yeah, thank you.
It's yours. Here you go. Okay. Well, you've probably read most of it because I assigned a number of chapters, but now you have a chance. You know, if for some reason you can't get to sleep late at night, you can read a couple of other chapters. Okay. Well, thank you, and good luck with your future endeavors.
Thank you.